Hello friends, how are you? How have you been doing? I hope you're doing good. My name is Naomi and this is the Easy QS channel. Welcome back for another video. We are looking at taking off substructure works, and we began in the last lesson where we measured or we explained how we measure site clearance. We remove the vegetable soil, we reduce the levels, then we come to the excavation of the trenches. Then after excavation of the trenches, we see that we have to compact the soil in the trenches, then support the sides of the trenches so that they do not collapse. I hope you remember what we did. I showed you clearly how to measure, and the rules of measurements that you're using in this class is the new revised methods of measurement. We see that different countries have different methods of measurements that they use. In Kenya, we use the standard method of measurements, SMM7. That is what we use. In other countries, we could find that they use like the new revised methods of measurement, or they can use the NRM2. All these methods of measurements differ from country to country, but the concept of measuring is always the same. So welcome back to this video. We'll continue from our previous video. If you haven't watched our previous video, find it in our description box so that you can be able to first watch that one, then come and join us so that we can continue. This is a very important part for all our quantity surveying students, and also diploma in civil engineering, where you have to go through the measurement class. And remember, this accounts to 30 marks in your exam. So when you are taking off, you just need to be just keen to see what we are doing. As I do, you should try and calculate so that you can be able to see whether you can get it. Then maybe you can use the question, try to take off yourself, then use our question here to mark. Alright, so before we begin, I have to tell you about our membership packages. If you want to join our live classes that are coming soon, kindly subscribe to our membership. If you need to know more about the membership, you can look into our packs, or also email me in my email, which is in the description box. Also, for all who would want to support our content, there's the content supporters package. You can always subscribe to that membership, and you are sure that you'll be able to see all our recorded videos that everyone else cannot see. For all our subscribers, we shall be having those classes very soon. Even for all our subscribers, the live classes, kindly join so that you can be able to ask these questions that most of the time maybe we don't find time to answer, or the question is so much repeated. You should come ask your question so that we can be able to answer it to you, and be sure to give us your feedback so that we can continue to improve the videos for you. So we shall get on to today's class. If you haven't subscribed, remember to subscribe. That is the support that we need so that we can continue to bring to you these videos for free. So today's class, we will begin from taking off the concrete in the foundations. When we talk about the concrete in foundation, is the strip foundation concrete. You see, we said if you have a house here and the house is rectangular, assuming this is our house, it's rectangular and these are the walls. This is our house here. These are our walls, and the walls are 200 millimeters thick. Assuming these are our walls, and the walls here, they are 200 millimeters thick, and this is the length of the house and the width of the house. We said if we have the trench usually, you see, so that you can understand the trench, we usually have the section, and the section will be there to show you that this is the wall. Once we take the section here, the section maybe it's AA, so the section will tell you that this is the concrete, foundation concrete. It's inside the trench, and this is the walls of the trench. The walls of the trench go up to here. We have the ground level, and here we have the reduced level. Right, so this is the trench. Assuming we are told this is 600 and the walls, they are 200 millimeters thick, we see that there is a spread in the foundation, 200 this side and 200 this side. So how did we get the 200? We took 600, we deducted the 200, we divided by 2 to get the spread on both sides. So once we come to the plan to sketch the trench will be outward. We have the spread of 200. Then inside we have a spread of 200 from the wall to the wall of the trench. From this outside external wall to the wall of the trench, it's 200. This is the foundation spread we are talking about. Then the other foundation spread is to the inside. We have this 200 here. Alright, so when we are doing the concrete in the foundations, you see that we have this concrete, this mass concrete in the foundation. Once we are taking off using the NRM form, the NRM4 states that we should take off concrete in terms of meter cubed. So once it is in meter cubed, this is the volume of the concrete. How do we calculate the volume of concrete in such a trench? We shall take the center line of the trench. I want to show you the center line very well using my red pen here. We see that the center line of the trench is the center line of the wall. When we are talking about the center, we mean 600, where we have the center of 600 is 300. And if you check, the wall is positioned at the center and the wall is 200. So the center of this wall also will be here. So if we can extend a line here, we shall say the center line of this trench is the same as the center line of this wall. You see the center line is this line here. That's the center. Now if we come round here, this is the center line. And we say that if we take the center line, then we multiply by the width of the trench, then we multiply by the thickness of the concrete, we'll be able to find the volume of the concrete. So if the concrete is in meter cubed, we shall say volume is equals to length times width times height. So if it's length times width times height, the length here is the center line. The length is the center line. The width is the width of the trench. Then the height is this thickness of the concrete. Right? So that will be the volume of the concrete inside the trench. Assuming there was an internal wall here. Assuming that there was an internal wall here. I always want to give these examples so that you don't get confused once you find an internal wall. If we have an internal wall here, the spread of the trench shall be, we just have to have it spread. Maybe the section is the same as this one. Maybe this one and this wall is the same in this case. So the spread here is 200 and the thickness of the wall will be 200. To find the volume of the concrete in this wall, we shall take the center line of this trench. You see, we have already done concrete in the whole trench. Because if you check, the concrete occupies the whole trench, the whole width of the trench. So from the broken line to the broken line outside, here we have concrete. Everywhere we have concrete. So what is the area that is remaining from here to here? You see, the concrete has come already from here to here. That one we have accounted for. So the remaining concrete is from here up to here, this length here. So we shall take the center line of this trench, which is at the center, which will be from here. So not very keenly, it is not from here up to here, because this whole area has already concrete. This one has concrete. So when we are accounting for the concrete in the internal wall, we shall measure from here up to here. So this shall be the length times the width times the thickness of the concrete. So this one was for the external wall. So this one will be the total center line going round times the width times the thickness. Now for the internal wall, it shall be also length times width times height. This length is the center line of the internal trench. Center line of internal trench. not internal wall, because it's from here up to here, not from here to here. Alright, so that one I hope is well understood. So it shall go depending on the sizes of the wall. Maybe in this case the wall was smaller. You could have found that the section for that wall, you could find that this wall here, you're told that it's an internal wall, so it's 100 millimeters thick. Then we have the concrete, which is maybe this one, they did a concrete of 400. All right, the thickness of the trench is 400. So once we are finding the volume of concrete from here to here, you'll take 400, we deduct 100, it shall be 300. To find the spread is 300 divided by 2. So 150, 150. So the spread here shall be 150, here 150. So when you are finding the volume of the concrete from here to here, we shall take the dimensions from here to here times the width, which is 400, times the thickness that you're given here. Alright? So that it doesn't need have to worry you if the thickness of the walls are different or the thickness of the trenches are different. So we shall continue from the concrete and we shall go to the other part, which is measuring the internal skin in cavity walls. So we'll go to the next part, which is measuring the walls in a cavity wall. In countries where we have cavity walls, how do we measure the skins within the cavity wall? You know, the cavity wall is usually made up of two walls. So we have the external wall here and the internal wall. And inside here we have a space. That space is called a cavity. Alright, so this external skin here, it's made of brickwork. That one is the one that usually have the bricks for a good finish. Then inside here we have the blockwork. So once we have a cavity wall and it has two skins, one for the brickwork outside here, then blockwork inside here, we need to measure for when we are constructing. And once we are taking off so that you can come up with a bill of quantity, we need to measure the areas of the brickwork and the blockwork. Then we shall also come to the cavity. So we'll start with the external skin, which is the brickwork. How do we measure the brickwork? The NRM2 states that we should measure the brickwork in meters squared. Alright, so if we say meters squared, that is in area. Area is equal to length times width. Assuming we have the plan is here. The plan is made of cavity walls. In cavity walls we have that wall here, that is the blockwork. Then we have the space, then we have the brickwork. Let's see how it is. We have the brickwork here. Alright, in the plan we'll be able to see all these walls. So this is the brickwork outside here. Then brickwork. Then we have the blockwork inside here. Blockwork. Okay. Now that we have the brickwork and the blockwork inside the plan, we can be able now, that is the plan and this is the section. So once we are measuring for the brickwork is the outer skin. So that we can be able to measure the area of the brickwork, we need the center line of the brickwork. The center line will be this line here. Alright, this line here. So this is the center line. We go passing through the center. That center line, then we multiply by the height of the brickwork, right? So we shall take the center line of the brickwork, assuming we had been given the dimensions from here to here, so that we can get the center line for this brickwork. Or assuming we had the dimension, external dimensions from here up to here, the external dimensions of the house. To get the center line for the brickwork, what do we need to do? We need to find the external perimeter, then we deduct number of corners times the thickness of the brickwork. If you haven't seen our video on calculating the center line, you need to check it out, and we shall pin it in the description box so that you can be able to see how we do the center line calculation and practice it, because in taking off we need center line calculations. So in simple times, what we shall do, we shall take the external perimeter of the building, we deduct number of corners, then we multiply by the center line, the thickness of the brickwork. So you get the center line of the brickwork. So once we take the center line, we multiply by the width of the brickwork. Width is the thickness of this brickwork, the thickness of this one. So that one, we shall have found the area of the brickwork. Now we shall go to finding the area of the blockwork. How do we calculate that one? We shall take the center line of the blockwork times the height. So how do we calculate the center line of the blockwork? We shall have to find this center line here. We shall come the center line of the blockwork here. Then we multiply by the height. Alright, so we shall get the area of the blockwork. So assuming we have the internal dimensions of this house, we can take the internal perimeter, then we add number of corners times the thickness of the blockwork, so that we can get the center line of the blockwork. So that is how we find the areas of the both walls, the brickwork and the blockwork. The next item that we shall measure from the same is forming cavities. We shall calculate forming cavity including the wall ties. You see, between the two walls we have the space here, and that space we have said it's called the cavity. So this cavity to be formed, it requires some labor, it requires some materials. So to account for it, in the NRM2 we are told to measure forming cavity in meters squared. So that one is the same as area again. So forming cavities, we shall take the center line of the cavity, which is here. Alright, forming cavity, this is the center line of the cavity. Then we shall multiply it by the height of the cavity. Alright, so measuring forming cavity including the wall ties, how we shall be able to price it? We should measure the area, then we shall price it per square meter. So for the area, it's length times width. Length is the center line of the cavity, then the height of the cavity from here up to where the cavity shall be for the substructure. Okay, so the next item is filling the cavity with concrete. You see, once the cavity is formed, there is some work that shall be done to form the cavity, placing the wall ties. The next thing is filling that cavity with concrete. We don't usually leave it as a whole. So filling the cavity, we are told to take it off using meter cubes. It's concrete. So we shall measure the volume of that concrete. How do we measure the volume of the concrete? We shall take the center line of the cavity, we multiply by the thickness of the cavity, then we multiply by the height of the cavity. So it shall be volume is equals to length times width times height. So the length is the center line of the cavity. This one is the thickness of the cavity. This one is the height of the cavity. Alright? So that one is filling the cavity with concrete. The next item that we shall do is the DPM, the DPC, the damp proof course. The damp proof course is usually placed on top of these walls. You see, in countries where we use cavity walls, we don't do concrete inside here. The concrete doesn't go to the wall. The wall starts from the foundation, they go up to the top. So we do not have the concrete, oversight concrete, coming to the wall. So what we do to prevent that water from the foundations going up the building, we place the DPC on top of the wall, then we continue building the superstructure walls. So to measure the DPC is usually measured in terms of linear meters. So when we are measuring in terms of linear meters, we shall come, the DPC is placed below the, above the brickwork and above the blockwork for the foundation. Here, above here, all around the building. So we shall calculate the center line of the brickwork for the DPM for the brickwork. Then we shall take the center line for the blockwork to get the length of the damp-proof course for the blockwork. Alright, so DPC is usually measured in linear meters. Then where it is, the walls are less than 300 millimeters wide. Yes, so maybe in case the walls are more than 300 meters squared, 300 meters thickness, they could be measuring using meter squared. If you're told to measure using meter squared, you just need to take the center line times the thickness of the wall. But in case they are less than 300, it is in linear meters. So it is the center line for the brickwork, then center line for the blockwork, so that you can get the total length of the damp-proof course. The next item that we shall measure is the adjustment that we shall do for facing bricks. Remember, the bricks are used for mostly for the aesthetics of the house. So the superstructure bricks needs to be very beautiful, so we use facing bricks. The bricks above the ground level, they are not the same as the ones that are below here, because those above the ground level needs to be beautiful, and we use the facing. So we usually do adjustment now that we had already calculated the brickwork up to the top here. But these bricks which are here, you see this, if this is the ground level, these bricks that are here and here, they are on top of the ground, so they are facing bricks. We need to do some adjustment, some change to the brickwork that we had taken off. So these two courses, we need to adjust them, and they should be on the superstructure side. So how we measure that is in meters squared. So what we shall do, we shall take the center line of the brickwork, just like we had taken it, then we shall multiply by the height, because we should measure for the adjustment of the facing bricks, but in terms of meters squared. So we shall take the center line of the brickwork times the height that we need to adjust. Then the center line of the brickwork times the height. After all, this is the same house. So we shall take the center line for this brickwork times this height that we need to adjust for the brickwork. And we have said those brickwork, they are the ones that will be on top of the soil, on top of the ground level. Okay, so the next item that we shall deal with is backfilling of the trenches. I see that we have a cavity wall here. We have said this is the brickwork outside, then we have the blockwork, then we have the cavity inside. But now, if you can see, we have brickwork, blockwork, and cavity. We have the foundation spread on both sides. On the plan, this will be the foundation spread on the outside, and this will be the foundation spread on the inside. So once we are backfilling the spread outside, this space in the trenches, you know, we need to backfill with soil after we have constructed the wall. When we are returning the soil, that is what we are calling backfilling. We need to measure for the backfilling to the external faces of the wall. External face is, this is the external wall. So outside here we need to backfill. How do we measure the backfilling? We are told to measure it in meters squared. The NRM2 states that we should measure it in meters squared where the thickness, the spread, is less than 500 millimeters. Then where the spread is more than 500 millimeters, we should measure it in meter cubic. So let's see how we do it. To fill the soil, this outside here with soil, up to where should we fill it? We should fill it up to a level here. So to fill here, this volume of soil all around the building, how do we calculate it? We shall take the center line of this external trench here, this center line of this foundation spread on the outside. In other words, you see, This is the spread on the outside. So we should find the center line of this one. Once we find the center line of that one, we should multiply by the thickness of the, in case it's more than 500, we shall multiply by the thickness of that foundation spread, then we multiply by the height. If it is less than 500, we shall take the center line, then we multiply by the height. Because we are told to measure it in meters squared if the spread is less than 500. So if it's less than 500, center line times the height. If it's more than 500, it shall be center line times the thickness of the spread times the height. Alright? So that one is the backfilling to the external trenches, to the external faces of the trench. Okay, so the next part that we shall, we have filled up to here. Why? It is because first of all, we started with from the ground level here. We removed the vegetable soil, 150. Then from the vegetable soil removal, that's when we came to reduce the level up to this level. Right? So we usually backfill up to the area where we remove the vegetable soil. The other area, we shall backfill it with separately. That one usually call it not to backfill, it is to reinstate the soil, to go back to the ground level. So once we are backfilling the soil in the trenches, we usually fill it up to the level where we strip the ground out of the topsoil. Then once we get to the stripped level, the other height shall be accounted for when we are reinstating the soil to the ground level. Alright? Okay. So the next item after reinstating the soil up to this level, we have already returned the soil up to this level. We haven't filled it up to the ground level. Assuming we backfill the soil up to this level, that means that between the house and the rest of the ground, we shall leave a hole. And because that is not normal, we need to backfill the vegetable soil that we had removed so that we can go back to the ground level. So in this case, we shall measure it, stating that we are backfilling the external faces with previously excavated topsoil. This soil, from here to here, we have to use the good soil. But this soil, in case we do not have soil, we can use the topsoil that we had removed. Alright, so to measure for this volume of soil going all around the building, we shall take still the center line for the trench outside, then we shall multiply it by this height, the height of the vegetable soil. If we had removed the height of 150, that one shall be the center line for this spread on the outside, then we multiply by that height. Alright, then we shall come now to the next item, which is backfilling the internal faces with hard coal. Up to here, we usually place in hard coal until we get to the reduced level. How do we go about it? We shall find the center line for this spread in the inside. Find this center line. So how do we find that center line? We shall come to this spread on the inside. Remember, this is the brickwork, the cavity, the blockwork. So this is the spread of the foundation to the inside. So we shall take the center line. Everything here we use center line. So we shall take the center line of the spread on the inside. Then we shall multiply by the height of the hard core. In case we are finding using meter squared, but hard core at the NRM states that we should use meter cubed. Meter cubed is volume, and volume is the same as length times width times height. So length, it will be the center line of this spread in the inside. We shall multiply by the width, that is the thickness of this spread. Then we shall multiply it by the height. Alright? Okay, so we shall now move on quickly to the next item, which is compacting the ground. Now that we have already backfilled the trench, here we have soil, we have constructed these walls, we have done the cavity, we have filled it with concrete, we have backfilled here with hardcore. Now we shall need to compact this ground level here. We shall compact all this area here. Here it's inside the building. we need to come and compact. All right, compacting is usually measured in meters squared, and if it's meters squared, it's length times width. If you see in the plan, compacting, we shall compact from the inside face of the wall here. This area we have filled it with hardcore, but even on top of the hardcore will be part of the floor. So we shall find the length. The length will be this length of the internal wall. Then the width shall be the width of the internal wall. So all this area shall be compacted. So this area shall be the length from here to here, the width from here to here, because all that area from this surface of the wall on the inside, surface of the wall, the internal wall, we shall take length times width. All right, so we shall take the length times the width. All right, so the next item, after compacting the ground, we need to fill to make up the levels with hardcore. After compacting, we just need to do some hardcore. Here we had hardcore, and here now we need to do another layer of hardcore. We just compact, then we come and do hardcore here. So in case we are doing hardcore here, and the NRM states that we should measure hardcore in terms of meter cubic. So it states that we shall take the length and width times the thickness of the hardcore. So if we come to the plan, we shall take the length, the width, then the thickness of the hardcore. That one we're stating it as filling to make up levels with hardcore, usually measured in meter cubed. All right, you need to check out on our video, and our next video I'll be able to show you through a presentation these diagrams that we have here. I think they are a bit more clearer, so that you can just go through them and see exactly what we say on paper. So in case you don't understand here, maybe you can look up to the next presentation so that you can be able to see clearly what it is by examples. But this one I have done it so that I can be able to explain to you. Okay, so on this area we have filled this internal trench with hardcore. Now from the side, from the face of the internal wall, all around this area inside the internal walls, that area shall be compacted in terms of meter squared. Then it shall be filled with hardcore, which is measured in meter cubed, and that meter cubed is usually calculated as length times width times the thickness of the hardcore. After we have done the hardcore in the inside of that building, the next item that we need to do is to compact that filling. The hardcore needs to be compacted. You realize that compacting is work that will need labor. So we need to account for it, and that's how we need to measure it. So we are told in the NRM2 that we should measure that compacting the filling in terms of meter squared. And when you're told meter squared, it's length times width. So we shall check the length. The length is from here up to here, width from here up to here, because this, remember, this one was the trench and it has been filled with hardcore. So this whole area shall be done hardcore. The same area that we have done the hardcore, the same area we shall compact the hardcore. Alright, so measuring the hardcore shall be in meter squared, so length times width. So it shall be the length of the internal faces of the wall times the width of the internal faces of the wall. After we have done the hardcore here, the thing after compacting that filling, we shall come and do the insulation. You remember, in countries where we have cavity walls, it is places where it gets so cold. So we have done the cavity wall for insulation so that the cold doesn't come into the house. Now we need to do insulation for the floors. Alright, so we don't want the cold to come to the floor. So here we shall do some insulation. This insulation in the NRM2, we are told that it should be measured in meter squared. And when we are told it's in meter squared, it is length times width. So we shall take the length times the width, because it is the internal area inside the wall, inside the walls. That's the area inside the house all of it, we shall do the insulation. It's measured in meter squared, that is area. So it is the internal dimensions of the house, that is internal length times the internal width. Then we shall go to the next thing, which is the damp proof membrane. The damp proof membrane shall be laid on top of the floor insulation. If it's laid on top of the floor insulation, we shall take it off by measuring it, and we are told in the NRM2 it is in terms of meter square, so it's the area. So the thing that you can observe clearly is that this area where we did the hardcore, the area of the hardcore, the area for compacting, first of all we started with compacting this area. We compacted the ground inside the house, then we laid the hardcore, same area, then we compacted the hardcore feeding, same area, we laid the floor insulation which is in the same area, that is the same area. Now we shall do the damp proof membrane on top of the insulation to prevent any moisture from coming up. So we are told the damp proof membrane is measured in terms of meter squared. So if it's meter squared, it is length times width. Alright, the same area. So we shall go to the concrete bed, because on top of the insulation bed, we shall come and lay our concrete bed now, the floor, the concrete. If this is our concrete bed, we are told that we should measure it in terms of meter cubed. If it's measured in meters cubed, it is length times width times height. So the same area, length times width, inside the building, the same dimensions, internal dimensions of the house, length times width. Then we shall multiply by the thickness of the concrete as the height. Okay, so after the concrete bed, now we need to do the something called the DPM abutment to walls. Okay, so the walls, something that we are talking about the DPM abutment is that we shall need to put a damp proof membrane on the sides where we shall have the concrete, where we have the wall, so that water doesn't come in through the outside to the concrete. We have already placed a damp proof membrane here to prevent any water rising from the ground to reach the concrete here floor. But then there is water coming outside from outside the building, so that it doesn't come to the floor. We place a DPM on the sides. Alright, so all around here we shall have the DPM. Okay, all around the internal dimensions of the wall. Alright, so that DPM is usually measured in linear meters, and in case we are told linear meters, that tells us it's the internal perimeter of that house. That's where we shall do the DPM abutment to the wall. It's measured in perimeter. So that is the whole process of taking off using the NRM2. That is how we do it. When you're told to measure it in meter squared, it's the length times the width. Where you need to use length as the center line, we have showed you clearly how you would go about using the center lines. Alright, so in case you have any questions, remember to write them in the comment section, and also we shall do a live video for the same, so that you can ask any questions. So be going through our videos, so that when we shall have our classes, you can be able to ask any question that you have. So thanks a lot for watching, thanks for subscribing, thanks for sharing our videos and giving them thumbs up, liking them. We really appreciate your support. So keep tuned, we shall be bringing more content to you, and feel appreciated. Have a good day.